Okay guys, we're going to look at how a power supply unit works and how it converts your AC voltage into a DC voltage for your application. So we're going to start off with our AC supply. So this is a typical supply of 230 volts at 50 hertz, which you would find in the UK. And I'm just going to put a load across the other side of that transformer so we can take a look at the voltage. So now if I run my simulation, so we can see from our transformer we're getting just over 25 volts and we've got an input voltage of 230 volts. The only problem is you can see in both cases it is an alternating current. You can see the waveform hasn't changed. So we want direct current, so I'm going to stop that simulation now, and we're going to use 4 diodes to allow the current to flow as a DC current, direct current. The special thing about diodes is that they only allow current to flow in one direction. So by configuring them in our bridge rectifier circuit, we should be able to achieve a DC current. And again, we're going to connect a load . And we will run our simulation and see what we get. Okay, so we're running the simulation and we can see a couple of changes. So we've still got our 230 volt AC supply, and that's going to be moving along nicely. On the output voltage, you can see we've had a little bit of a reduction in voltage due to the current running through the diodes, but you can also see sort of rippled effect as our output voltage. So we're getting a sort of a DC signal, but it's bouncing up and down a little bit. The way to remove that is to introduce a capacitor into the circuit. And what the capacitor will do, it will store the charge at the peak of the waveform, and as the waveform drops it will release the charge, give you a much smoother voltage output. So let's run our simulation again. And we can see there now that we've got this almost straight line voltage and current. You can see it sort of dips and then goes back up a bit, but it's more of a steady DC signal. You could improve that by changing the size of the capacitor or adding more capacitors if you really wanted to, but for our application here this is perfectly okay. So just to recap then, we've got our 230 50 hertz supply voltage that's running through our transformer, which is dropping the voltage to around 24 volts. The voltage is then being manipulated through these diodes, which force the current just to run in one direction, and that was giving us that ripple effect across the load. And then we've added our capacitor, which helps smoothing out that DC signal. And this is typically how your power supply to your laptop or your phone charger or the power supply found in your PC at home change the voltage from an AC signal into a DC signal for use in sort of smaller electronic circuits. Thank you for watching, and I hope you found this video useful.